Hello there and welcome to a brand new lesson. This is Hub Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at arithmetic sequence, that is linear sequence. And by the end of this lesson, you should be able to define an arithmetic sequence and identify the common difference D. You have to be able to determine whether a given sequence is arithmetic by checking the consecutive differences. And then you'll be able to state the first term, that is A, and the common difference D of any arithmetic sequence. And then you should be able to use the general formula UN equals A plus N minus 1D to find any term. And finally, you should be able to apply the arithmetic sequence to model and solve real-life problems. So without much ado, let's quickly look into it. So let's start by asking the question, what makes a sequence arithmetic? So we say a sequence is arithmetic if and only if the difference between every pair, take note of this, every pair of consecutive terms is exactly the same. Now this difference is what we call the D, or the constant difference. To find this D, this is what we do. So if you have a series of, or if you have your sequence displayed, that is your U1, U2, U3 to the fourth term, and then it goes on. Now you would have to compute U2, that is the second term minus the first term, and then also compute the third term minus the second term, and also compute what? The fourth term minus the third term. That is to say, you'd compute the n plus 1 term minus the n term. You see, if all these are equal, then you can see your sequence is arithmetic. The D we want here, which we obtain it by what? Subtracting n minus 1 term, that is n minus 1 minus n. What happens is the D can be positive. You see, so your D you want can be positive. If D is positive, then it simply means your sequence is going up. That is if D is positive. Now, if D is negative on the other hand, then it simply means your sequence is coming down. Then finally, if your D is 0, then it simply means the sequence is just a constant. We are calling an arithmetic sequence a linear sequence because its graph is a perfect straight line. Take note of that. So it is called a linear sequence because its graph, if you graph out an arithmetic sequence, you get a straight line, a perfect straight line for that matter. So here's a quick test here for you. We have 3, 7, 12, and then 18. Let me know in the comment section if this is arithmetic. So with that said, let's look at the general term formula. The general term formula of an arithmetic sequence. So talking of the general term formula, before we even consider that, we need to know what the general term is. The general term is just a formula that gives the value of the nth term without listing every term before it. What we simply mean is, if you have a sequence and you want to list the 30th term, you wouldn't have to list the first, second, third, fourth till the 29th before getting the 30th term. The general term gives you a formula that you can use to determine every term without necessarily listing out all the terms that precedes it. Example, if I take this formula here that says UN is equal to 3n plus 4, I can list my first term. So that is, if n equals 1, then I'll be listing my first term, which becomes what? 3 into bracket 1 plus 4. And this gives me what? A 7. If I want my fifth term, that is to say n equals 5, I have my what? U5, which becomes 3 into bracket 5, then plus a 4. 3 times 5 gives us a 15, so we have 15 plus 4, which gives us a 19. I did all these without necessarily having to start from the first term, second term, third term, and then till I get to the fifth term. That is what we call the general term. So there's a general formula we use to get this general term, and that is what we want to talk about. So the general term formula is written as what? Un, that is the general term, is equal to a plus into bracket n minus 1 bracket close, then your d. And take note, the a we have over here is the first term of the sequence. The d, on the other hand, is the common difference, and the n is the position number. The position number here would mean if you want your first term, n becomes 1. If you want your third term, n becomes 3. You see, if you want your 10th term, n becomes what? 10. So it says, think of it as you start at a, then you add d exactly n minus 1 times. That is how the formula is developed. Now it is important you take note of the first term, because it is through the first term that everything else is built. So the first term, which is a, is the starting value of the sequence. You can also write it as u1. Everything is built from this. So the first term of a sequence is very, very important. So let's take this example and see if we can identify our first term. It is actually easy to identify. We have 7, 11, and then 15. Just this is fine. So what is our first term? Our first term, which we would call our a, is simply 7. That is the first term of the sequence. It can also be written, as I said, as what? U1. Now that we know the first term part of the formula, let's talk about d. D. So the d is simply what we call the common difference. And when we talk of common difference, we simply mean the fixed value added to each term to get to the next. You see, now it is found by d equals u2 minus u1. That is the preceding one minus the previous one. Anytime you can use this formula to solve your common difference. And there is something interesting about the common difference. This interesting fact is that when you have an arithmetic sequence and then your d is greater than 0, then the sequence increases. So you start from a smaller number and then gradually gets toward a bigger number. On the other hand, if your d is negative, then the sequence is actually reducing. You reduce and then even enter into the negative domain. Then when your d is 0, then you would always get a constant sequence. So it is important we take note of these as we proceed. Now one might also ask, we have spoken about the a, we've also spoken about the d. Where does this n minus 1 comes from? I'll give you a very short and simple proof where it comes from with an example. Let's say we have all these terms over here. That is u1, u2, 3, all the way to 5. We know our u is actually, the u1 is actually a. So I can rewrite all of this and then just clean my u1 and substitute it with what? My a. Okay. Now from here, how do we get our d? So d is simply so I can say my u2 minus a, right? Which is also the same as u3 minus u2, which is also the same as u4 minus u3. I hope that is clear. Now, if we are to agree that this is a linear sequence, Then if I have my A, to get my U2, then it's simply going to be my A plus the common difference, which is D. This becomes my U2. If I want my U3, then it's going to be this one, then we add the common difference to it again. So it is A plus the common difference, which is what we have here, then plus the D. For my fourth term, is going to be all of this plus the D again. So A plus D plus the D, which is this term, then we add the common difference to it. Let's end here. Let's not go to the fifth one. If you have to simplify all of this, then we are going to get our A. Then for the second one, we have A plus D. For the third one, we have A plus there are two of the D's, so 2D. For the fourth one, we have A plus 3D. And looking at how things are going, it is obvious that for the next one, it's going to be A plus what? 4D. Meanwhile, A was our first term. A plus D was our second term. That is the U2. A plus 2D was what? The third term. That is U3. Then A plus 3D was our fourth term, followed by the fifth term we have over here. You realize that if it is the second term we want, then the coefficient to the D is what? 1. If it is the third term we want, the coefficient to the D is what? 2. If it is the fourth term we want, the coefficient to the D is what? 3. That is why generally we say that for every term UN, we first need our first term, that is A, then plus for the term we seek, let's subtract 1 from it, then multiply it by D, as you see demonstrated over here. So this is an explanation to the general term formula. Now let's look at how we can build the formula step by step when given a question. So this is the 4-step process I'll take you through as we answer our questions. First of all, we should always identify our A. You see, so to get our general formula, let's identify our A. Let's solve for our D. You see, then we do our necessary substitution into the general formula. After which we now verify to determine whether or not if what we actually did was correct. If this was understood, then we can proceed to solve questions. We are going to solve 5 questions. The first one being the very basic, then it increases in order of difficulty. I would always advise that you should pause for each question, try your hands on it, and then you compare my suggested solution to yours. If there's any issue, you can always let me know at the comment section. So our question number 1, which will be very, very simple. Our first question here says we have to confirm the sequence is arithmetic and then state A and then D. Now this is the sequence we have here. So our solution. Now we know that if a sequence is arithmetic, then it simply means the difference between the consecutive terms is constant. So we build from this idea, and we know D is calculated by what? The n plus 1, then minus this one. So let's name the first D we want as D1. That is going to be what? The 13 minus 8. And 13 minus 8 obviously gives us a 5. Let's name the second D we want as what? D2. And that is going to be an 18 minus 13. 18 minus 13 gives me a 5. Then we want our D3. So that is a 23 minus 18. That gives us a 5. You can proceed to the last one. That is a 28 minus 23. And that also gives you a 5. Now you'd say that since our D1 is equal to our D2, which is equal to our D3, then it simply implies that the sequence is arithmetic. So with that, we can say, therefore, our A, we know A is always the first term. So our A is equal to 8, and then our D is equal to 5. As simple as that. That was all the question wanted from us. Question number 2. So we are now solving question number 2. It says, find the 10th term of the arithmetic sequence 6, 10, 14, and then 18. Now we know the general formula. So we say using the general formula. And what does the general formula say? It says UN is equal to RA, that is the first term, plus n minus 1 D. You see? So with this, observing from our sequence, we can say RA, which is the first term, is equal to what? 6. Then we now find for D. So the D is also giving us what? N plus 1 minus what? The nth term. In this case, let's use 10 minus 6. So using our 10 minus 6, we are going to get what? A 4. Now you quickly try to confirm whether or not it is the same throughout. So 14 minus 10 would also give us a 4. 18 minus 14 would also give us a 4. So you end over here. Now substituting into our general formula, then it simply means our UN for every term at all. UN is equal to A, which is 6, plus n minus 1 D, where D is 4. You see? So it simply means if our n is equal to 10, which is the 10th term we want, then our U10 is going to be what? 6 plus 10 minus 1 times 4. This gives us a 6 plus 10 minus 1 gives us a 9. So we have 9 times 4, which is a 6 plus a 30 what? 6. And 6 plus 36 then gives us what? A 42. So we can conclude by saying, therefore, what? The 10th term. So therefore, the 10th term is 42. As simple as that. You see? So the main thing is you understanding your formula. That is why I take time in my lessons to make you understand with the English. If you really understand, you can always solve any question on your own. Let's look at our third question. Question number 3 says, you have to write the general term UN for the sequence 3, 7, 11, 15 and use it to find U20. I think it is just as similar to the previous one we did. So we know first of all that the general term is given as what? UN equals an A plus n minus 1 times the D. And obviously from our sequence, our A is equal to a 3. So it is D that we want. So our D is given as what? UN plus 1 minus UN. So solving for our D, we have what? 7 minus 3. We know it is linear, so there is no need even checking. And the 7 minus 3 gives us what? A 4. So our D is 4. If D is 4, then it simply implies that our general term UN is giving us A, which is what? A 3. So 3 plus n minus 1 D, where D is also 4. You see, now this is our general term. We said we want U20. So for U20, then it simply implies that our n is equal to 20. So doing our necessary substitution, our U20 is going to be a 3 plus 20 minus 1, then times the 4. This, when simplified, gives us a 3, then plus, we are going to get a 19 times 4. So we have 3, and then so our 19 times 4 gives us a 76. Then we have 76 plus 3, which is equal to what? 79. So we can conclude by saying that therefore the general term is what? 4n minus 1. Then our u20 is what? 79. Now, where from this 4n minus 1? You see, our general term we solved for was this we have over here. But depending on how your algebra is, how good you are in these algebraic expressions, you can always simplify it further. I chose to write 4n minus 1 here just to alert you. So let's simplify this and we'll see how I got that. So this was our general term. If we want to simplify, we have our un being equal to a 3. Then if we are to open the brackets, the 4 multiplies the n, it also multiplies the negative 1. So 4 times n gives us a 4n. Then 4 times negative 1 gives us a negative 4. You see? So with that, if we want to simplify, we have our un being equal to grouping like terms, we have our 4n, then a positive 3 minus a 4, which ends up giving us what? A 4n then minus 1. You see? So instead of keeping it this way, if there is time, you can always simplify it. And using our n to be equal to 20, we can still substitute to get our 4 into bracket n, which is 20 minus 1. 4 times 20 gives us an 80, so you have 80, then minus 1, which is also a 79. So you could have stated that this is your general term, that is fine, but if you choose to simplify, this is also very simple, which helps you to get your U20. Let's look at our question number 4. For this fourth question, there are so many ways you can solve it, but let's read it first. It says, the fifth term of an arithmetic sequence is 29, and the eighth term is 44. You have to find A and then D and the general term. You can pause and then do it on your own, after which you come to look at my suggested solution. We know for a general term, un is given as what? A plus n minus 1, then your D. If you are being told the fifth term, that is to say u5 is equal to, using the same general term, we have our A, which we don't know yet, then plus our 5, which is the value of n. So 5 minus 1, then D. And in actual sense, this fifth term is equal to 29. So you can equate it to 29. Now, let's focus on what we have here and then we simplify. Okay. So with that, we are going to say we have our u5, which is equal to A, then 5 minus 1 gives us a 4. So we have 4D, you see, which will then give us what? A 29. Let's name this as our equation 1. Then we come to the second part of our statement, which says u8 is 44. So the eighth term, using the same general formula, it says A, then plus, this time around our 8 is the n. So 8 minus 1, and then D. Simplifying, we know it gives us 44 though, so we say it's equal to 44. It simply implies that our A plus 8 minus 1 gives us a 7. So 7D is equal to what? 44. We can name this as equation 1. Now, if you are good with simultaneous equation, then we can consider these two equations and solve them simultaneously. So this was our equation 1 and this was our equation 2. And we do want to solve them simultaneously. Let's do it in our next page. So with these two equations, I would want us to use the elimination method. So with the elimination method, we can quickly eliminate our A. Okay, so what I'm going to do is equation 2 minus equation 1. And that is to say, this equation 2 here, then minus equation 1, which is the very first one we have over here. You see? So anytime we want to subtract, you just bring this here so that it will enhance your clarity. And you include a bracket. If you are using a calculator, you can just quickly go straight forward and then solve simultaneously. But then, since I am doing it manually, that is why I'm choosing to solve it this way. So we have 44 minus 29, which gives us a 15. Then we have 7D minus 4D, that gives us a 3D. Then A minus A goes off. So at the end of the day, we have our 3D, which is equal to a 15. Hence, if it is D we want, we divide both sides by 3. This 3 cancels out this 3. Then we have our D, which is equal to what? 5. If you are able to get your D, all you need to do now is to substitute it into any of the equations to solve forward your A. So in this case, let's substitute D into equation 1. If you have to substitute D into equation 1, then we have our A plus, instead of 4D, we have 4 into bracket 5 because D is 5. And that is equal to 29. Simplifying further, we have our A plus 4 times 5 gives us a 20. We have 20 equals 29. Making A the subject, we have 29, then minus a 20. Hence, our A is equal to 9. Now back to the question. The question was we have to find A and D and then the general term. First find A, find D, and then the general term. So we can quickly say that, therefore, our A is equal to 9. Our D, on the other hand, is equal to 5. Then for the general term, that is our UN, is giving us what? So your A first, that is 9, then plus n minus 1 D, where D is 5. And as I said earlier on, if you would want to simplify this, which is best to do, we have 9 plus n minus 1 with our 5 here. And what does 5 do? 5 multiplies your n and also multiplies your negative 1. So that you are going to have a 9 plus 5n minus 5. This 5n is from 5 multiplying n, then negative 5 from 5 multiplying negative 1. That gives us, that is grouping like terms. We have our 5n, then n minus 5 gives us a positive 4. So instead of writing un equals 9 plus into bracket n minus 1 into bracket 5, as you see over here, a very simple way to write it is to say your un is equal to what? 5n plus 4. As simple as that. This is when you actually want to use the simultaneous equation method to solve. But Depending on how well you understand your series and sequence, then there's a very simple way you can also solve it. Now you know that from U5 to U8 there are 3 steps of D. So that is to say there are 3 steps of D. How do we know there are 3 steps of D? If you are on U5, you need to add a D to it before you can get to what? A U what? 6. And if you're on U6, you need to add what? A D to it before that gives us what? A U7. Then from U7, you need to add another D to it, and that gives us what? Our D8, our U8. So that is to say there are 3 steps of D. You see. So in simple terms, with this I'm explaining, if you were okay with the substitution, you can skip to question 5. But if you still want to get this, then we can simply say that then our U8 minus U5 is equal to what? 3D. You know why we are saying 3D? Because we have skipped D 3 times. We needed to add the difference 3 times. And we know from our question that our U8 was given us a 44. And then our U5 was also given us a 29. We are saying that is equal to what? 3D. If you have to evaluate this, we have 15 being equal to what? 3D. If you have to solve this, you simply get your D to be equal to what? 5. You see? So from D being equal to 5, we have been able to skip all these equations and then we have gotten this. You see? So with that, you can simply use any other method to find your A. If you like this formula, you can let me know in the comment section and I'll do more of this in due time. Let's look at our last question. That is question number 5, which is an application question. This last question here says, a school library adds 12 new books every month. Now in January, it had 85 books. It says, in which month will the library first have more than 200 books? So let's write down our parameters. It says a school library adds 12 new books every month. This is simply to tell us that the common difference, that is after every month, our D is going to be what? 12. Now in January, we are going to start with January. So our first term is what? 85. This informs us that the general formula, that is UN, will be, which is A plus N minus 1 into bracket D, is going to be what? UN equals A, which is an 85, then plus N minus 1 times 12. If you do want to simplify this, then we have our UN being equal to an 85 plus 12n minus 12. 12n from here, that is 12 times n, and then 12 times negative 1 gives us the negative 12 we have over here. Simplifying further, we have our UN being equal to an 85, being equal to, since we have 85 minus 12, we are going to get what? A 73 plus 12n. So this is our general formula. Now it says, in which month would the library first have more than 200 books? If the library is to have more than 200 books, then that is an inequality question. So it simply means our general term UN should be greater than what? 200. And we know what UN is. So it also implies that 73 plus 12n should be greater than 200. You see, so the term we are talking about, its value should be greater than 200. And hence, we solve what? This inequality. So making our n the subject, we are going to keep our 12 on the left-hand side. Then it's greater than 200 minus a 73. Simplifying, we have what? A 12n, which is greater than 200 minus 73, which gives us a 100 and what? 27. So we would need to divide both sides by our n, by our 12. So that this 12 takes out this 12, and we have our n, which is greater than, you have to evaluate this, you are getting a 10.58 on your calculator. Now our n over here must be a whole number because we are talking of what? Month. So with this, let's approximate n to what? 11, because our decider here is 5 or more. Now the 11th month is in November. The 11th month is in November. So you can say, therefore the library will first exceed 200 books in November. You see, so in November, n equals 11. Now a quiz for you. If n equals 11, how many books will they actually have in the month of November? Pause and solve and let me know in the comment section to confirm whether or not there will be more books than what? The 200 as speculated. This brings us to the end of this lesson. But as usual, I'll leave you with an exercise for you to try on your own. So here you are with just 5 questions to test your understanding on all that we have done. If there's any issue of concern, you can always let me know in the comment section. This is Hard Beyond Numbers, where we learn maths the easy way. If this is your first time on this channel, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. Do stay blessed, and then bye. See you in our next lesson.